In this video, we're going to start talking about angles. So when you take a class in trigonometry, angles are a very important part of any topic that you're going to talk about in trig. So an angle, and we'll call it AOB, consists of two rays, R1 and R2, with a common vertex O. So if you're not familiar with what a ray is, sort of think of it like an arrow. So what we're saying is we have like a dot, and we've got one arrow going this way and one arrow at some rotation from that initial arrow. So we have something like this, and just to keep our picture mathematically correct, we'll label all of our points. So we'll have A, O, and B, and then this would be ray 1, and this would be ray 2, and then our angle is this distance in here, and we'll call it a Greek letter that we call theta. So when you see names of angles, they're usually named with Greek letters. So this could be things like alpha or beta or theta, like we just chose, or phi. So we could have like alpha looks like a little fish, sort of like that. Beta looks kind of like a cursive B. We have theta, which is like a circle with a straight line through it. And then phi is sort of like a little circle with a strike through. So those are some examples of names that you could see for angles. So an angle can be anywhere you want on a coordinate plane, but we have one special way of orienting an angle that we like, which we call the standard position. So if we want to talk about the standard position of an angle, and we usually do, then the vertex will be the origin of our coordinate plane. So that just means the point 0, 0. And then our initial ray is going to be the positive x-axis. And the terminal ray will be some rotation. So some angle of rotation from the positive x-axis. Okay, and this rotation could be in either direction. So if we rotate in a counterclockwise direction, then our angle is going to have a positive sign on it. So positive angles are a counterclockwise rotation. And if we rotate clockwise, then we would have a negative angle. So negative angles will be a clockwise rotation. And then finally, we have a special type of angle that we call a coterminal angle. So coterminal angles are basically angles that are in the same position, but they have different names. So that's how we're going to define coterminal angles, and we'll do some examples a little later. So we'll say angles in the same position with different names. Okay, so this is just a little basic definitions about angles, and so now we're going to talk about how do we measure angles. So there are two main ways that we measure angles. We have radians and we have degrees. Now you're probably very familiar with degrees. You've probably learned that ever since you started measuring angles with a protractor. However, we're going to talk about a really nice unit called the radian, which we also use to measure angles. So 1 radian is the measure of an angle that intercepts an arc equal in length to the radius of one circle. Equal to the radius of the circle. So whatever your circle is, 1 radian is basically the length along the circle that's the same as the radius. So the way we abbreviate this unit is just RAD. So let's think about what this looks like. So if we actually draw a coordinate plane, so we draw all 4 quadrants, and then we think about a circle. So it might look something like this. Okay, so this is your radius right here. So the distance from the middle of the circle out to the end is what we call the radius. So imagine taking that straight line and curving it along the circle. So like, let's say we say that's about 1 radian, well, maybe I should. Okay, maybe 1 radian's about right there. Maybe 2's about right there. 3 is going to be just before that 180 degrees. And then we have 4, 5, and then 6 might be somewhere right there. So this would be like 1 radian, 2 radians, 3 radians. 180 degrees is actually pi radians, so we're going to put that special number in there. Then we'd have 4, 5, 6, and then 1 full rotation is 2 pi. So what we get from this is that nice little circumference formula that you might remember when you learned about circles maybe in high school. So if you recall, the circumference of a circle is 2 pi r. And so why is that? Well, we just said that 1 full rotation around the circle is 2 pi. So basically we're saying here with the circumference that we're finding the distance around the circle, and it's got to be based on that 2 pi because that's the number of times the radius fits in one circle. Okay, so that's the idea behind radians. On the other hand, 1 degree is equal to a rotation of 1 over 360 of a complete revolution about the vertex. So all this means is that in a circle, there are 360 degrees. So hopefully you know that already, but if you don't, now you do. Okay, so it might be useful to talk about, well, how do we go between these two units? So that's where this conversion factor comes in. And basically writing it as a fraction like this allows us to organize and cancel our units. Okay, so that's going to be important when we go to converting our angles in the next few examples. All right, so I just want you to keep pi radians over 180 in your head. Okay, so finally we're going to get to some example problems. So for our first example, we want to convert each angle measure and determine its quadrant. And we want to round degrees to 3 decimal places. So some of these will be in degrees, some of them will be in radians, and you have to convert to the unit that it is not. So our first one, we have 135 degrees. So the way that I do conversions is I think about it like if any of you have taken chemistry before, you might have talked about something called dimensional analysis. Maybe not. But the point is we want to keep our units together so that they're going to cancel. So I'm going to start with my 135 degrees, and I'm going to set up my conversion factor so that my units will cancel. So in this case, I'm going to have 180 degrees on the bottom and pi radians on the top. So notice what happens here is my unit of degrees is going to go away. And so what I'm going to do is I'm just going to multiply across the top and divide everything across the bottom. So in my calculator, I would want to do 135 divided by 180, which would be 3 over 4. And then we just keep the pi off to the side. So this would be 3 pi over 4 radians. For our next example, we have 15 degrees. So I'm going to do the same exact thing. So I'm going to set up 15 degrees. And I'm going to think about how do I multiply by my conversion factor so that the degrees cancel out. So in this case, it's going to be the same as the one we just did. So I'm going to put 180 degrees on the bottom and pi radians on the top. And so what we end up with, if you were to put 15 divided by 180 into the calculator, you'd end up with 1 over 12, and then you'd keep that pi multiplied off to the side. So what we end up with is pi divided by 12. Okay, so now let's look at the angle negative pi over 2. So notice that this one is starting in radians, and we're going to go to degrees. So I'm going to do the same kind of thing, but I need to multiply a little differently by the conversion factor. So I'll have negative pi over 2. And then I need to think about how do I multiply this conversion factor so now the pi's cancel out. So I have pi radians on the bottom this time, and I'll have 180 degrees on the top. So notice this time, pi and pi cancel out. So basically what I'm doing is 180 divided by 2, which gives me negative 90 degrees. Okay, and for the next example, we have 5 pi over 6. So if there's no unit written next to the angle, we're going to assume it's radians. Otherwise, if you see a degree symbol, that's when you assume it's degrees. So be very careful when you're writing your answers. Make sure if your answer is supposed to be in degrees that you write a degrees symbol. If your answer is in radians, you don't need to write a symbol, but you can write RAD if you would like. So let's get back to 5 pi over 6. So we're going to do something similar to the negative pi over 2. We're going to take 5 pi over 6, and we're going to multiply by our conversion factor. So we're going to put pi on the bottom because we want the radians to cancel, and we're going to put 180 degrees on the top because we want our answer to be in degrees. So once again, the pi's are going to cancel out, and so what we need to do in the calculator is 5 times 180 divided by 6, which should give us 150 degrees. All right, we have a couple more examples of these to do, so I just want you to get really used to using this conversion factor. So our next one is going to be negative 270 degrees. So this time we're starting in degrees and we're going to go into radians. So we're going to start with negative 270 degrees, and we're going to again multiply by our conversion factor. So we need to put pi radians on the top because radians is the unit we want to go to, and we want 180 degrees on the bottom. So if we put 270 divided by 180 in the calculator, that should give us negative 3 over 2, and then we leave that pi off to the side. So another thing you want to notice is if I have a pi that I'm multiplying by, I'm not rounding that as 3.14. I'm keeping that as an exact answer of pi. So as we go through this class, you're going to notice that a lot of times we want to keep our answers in exact form. So that means I want to see the pi symbol. I want to see a square root maybe if that appears. Anything that keeps your answer exact. We don't want to make our answer decimals and round it. Okay? So hopefully that makes sense. All right, so our final conversion problem, we have 6. So 6 you might think is degrees, but we don't see a degree symbol. So we only want to assume degrees if we see a degree symbol. So we're going to assume that this is radians. So we're going to say 6 radians. And I want to convert to degrees. So I'm going to put 180 degrees on the top and pi radians on the bottom. So this one's a little weird because we don't have pi's canceling out. Okay? So for this, you're going to have to use the pi button in your calculator. So we're going to do 6 times 180 divided by pi. And that should give you a decimal of approximately 343.775 degrees. Okay, so in the directions, remember we said that if we got an answer that was degrees, we wanted to round to 3 decimal places. So just be sure that you're very careful with that rounding. Okay, so this is one example of a measure in radians that may not contain a pi. Okay. So there's one other form of an angle that we sometimes use. So this is like a special form of degrees. So when we talk about decimal form versus DMS form, we're only talking about angles that are in degrees. Okay. So DMS is short for degrees, minutes, seconds. So 1 minute, which we denote with a little tick mark next to our number, is equal to 1/60th of a degree, and 1 second, which we denote with a double tick mark next to the number, is equal to 1/60th of a minute, or 1/3600th of a degree. So what we're talking about here are fractions of degrees, but maybe sometimes we don't want to write it in decimal form. Why? I don't know. I think this is used in navigation sometimes, like when we're talking about going like sailing or something like that. I think that's where they use these kind of angles. So we're going to practice converting these a little bit. So our first one, we have 50 degrees, 6 minutes, 21 seconds. So we have our degrees, minutes, seconds form, and we want to get into decimal form. So the key here is to take the minutes and the seconds and get them into degrees. So let's start with the 6 minutes. Okay, So just like with our other conversion factors, we're going to multiply by something, but it's going to be a little different than the pi over 180 that we've been doing so far. So this time we want to think about how many degrees go into 1 minute. Well, if we go back to our definition, 1/60th of a degree is 1 minute. So I'm going to put 1 minute on the bottom because I want that unit to cancel out. And I'm going to put 1/60th degrees on the top because that's the unit that I want to get to. So then all I have to do is multiply across the top, divide across the bottom, and so if I do this in my calculator, I'm going to get 0.1 degrees. So 6 minutes is equal to 0.1 degrees. So I've converted the minutes. Now I need to convert the seconds. So I have 21 seconds. And I'm going to do something similar. So if I go back to my definition, I see that 1 second is equal to 1/3600th of a degree. So remember, we want to get to degrees. So we could use this definition in terms of minutes, but it would be much easier if I just used the fraction that has to do with degrees. So I'm going to put 1/3600 degrees on the top because I want to get to degrees. I'm going to put 1 second on the bottom because I want to cancel out the unit of seconds. So if I multiply 21 times 1/3600 in the calculator, I should get 0.00583 roughly degrees. So now what I need to do is I just need to add all my numbers together. So I still have 50 degrees, so notice my first, I guess, place value here was 50 degrees. And then I want to add my minutes, so I want to add the 0.1, and then I want to add my seconds, so I want to add the 0.00583. And so if I add all three of those numbers together, I just get 50.10583 degrees. Okay, so that is how you start in DMS form and go into decimal form. Now we're going to go backwards. So we're going to start in decimal form and we're going to get into DMS form. So let's see how to do this. So our degrees are going to stay the same, and what I mean by that is like this whole number on the outside, you're going to keep as 21 degrees. So really the only part we're going to be looking at is this decimal that comes after the degrees. So we want to take our 0.256 and convert it into minutes. So we're going to take 0.256 degrees and we're going to multiply by our degrees and minutes conversion factor. So we have 1 minute per 1/60th degrees, which if I divide 0.256 by 1/60, I should get 15.36 minutes. So what this tells me is that the second part of my answer is going to be 15 minutes. Okay, and then I need to take that decimal of the minutes and convert it into seconds. So I'm going to take 0.36 minutes and I'm going to say, well, how many minutes goes into, or how many seconds go into a minute? So I'm going to say 1 second is 1/60 of a minute. So I'm going to take my 0.36, I'm going to divide by 1/60, and in the calculator this should give me 21.6 seconds. So I'm going to round that up to 22. So our final answer is 21 degrees, 15 minutes, and 22 seconds. Alright, so the next thing we're going to talk about are coterminal angles. So remember that these are two angles that are in the same position but they have different names. So to be coterminal, the difference between two angles must be a multiple of 2 pi or 360 degrees. And that's going to depend on what unit your angles are given in. So let's think about why this makes sense. So if we're talking about two angles that are in the same position on a circle, and a circle is 2 pi, or 360 degrees around, it makes sense that for two angles to be in the same position, they have to be 2 pi, or 360 degrees apart. So let's look at our first example. We have negative 693 degrees and 27 degrees. So all we're going to do is we're going to subtract our two angles. So we have negative 693 degrees minus 27 degrees, and this gives me negative 720. Now negative 720 is just negative 2 times 360. So what we've done is, you can imagine starting at negative 693, going twice around the circle, and then you end up at the other angle. So because we got a multiple of 360, these two angles are coterminal. Okay, now let's look at an example in radians. So we have 17 pi over 12 and negative 19 pi over 12. So again, I'm going to subtract my two angles. So I have 17 pi over 12 minus negative 19 pi over 12, which gives me 17 pi over 12 plus 19 pi over 12, which is 36 pi over 12. And if I fully simplify this, that gives me 3 pi. Now, 3 pi is not a multiple of 2 pi. So there is no way I can multiply a number, not a fraction now, just a regular number, by 3 pi and get some multiple and get 2 pi. There's no way. So 3 pi is not a multiple of 2 pi. So these two angles are not coterminal. Okay, so this tells me not coterminal. All right. So that is how you tell that two angles are or are not coterminal. So now what we're going to do is, now that we know how to tell if two angles are coterminal, we're actually going to find some coterminal angles given an angle. So in this first example, we're given 272 degrees. So I want to find two positive and two negative angles that are coterminal with 272 degrees. So since we're in degrees, I'm just going to stick with, we need a multiple of 360. And this can be any multiple you want. But I think it's easiest just to stick with smaller numbers. So the smallest we can go is starting at 272 and adding 360. And then starting at 272 and subtracting 360. So if I do this, I get 632 for the first angle, and I get negative 88 degrees for the second angle. So that would be one positive and one negative angle that are coterminal with 272. If I wanted to find another positive and another negative, maybe I could just add and subtract 720. So I could do 272 plus 720 degrees, and 272 degrees minus 720 degrees. So let's see what this would give me. This would give me 992 degrees and negative 448. So the name of the game here is, again, you can pick any multiple of 360. Just make sure that some are added and some are subtracted so that you have the correct number of the angles that they want. Okay, let's try another one. So our next one, we have negative 75 degrees. So once again, I'm just going to pick some multiples of 360. So why not start with the smallest? So we can do negative 75 degrees plus 360 degrees. And I can do negative 75 degrees minus 360 degrees. And these two are going to give me 285 degrees and negative 435 degrees. Okay, and then let's say I add 720 and subtract 720. So we have negative 75 degrees plus 720 degrees and negative 75 degrees minus 720 degrees. And the first one is going to give me 645 degrees, and the second one is going to give me negative 795 degrees. Okay, so those are two positive and two negative angles that are coterminal with negative 75 degrees. So now let's look at some examples that are in radians. So sometimes people have trouble adding fractions. So that's why I think these radian problems give you some good practice. So remember here, since we're in radians, we're not going to think about it as 360 degrees. We're going to think about it as 2 pi radians. Okay, so if I have pi over 6 radians, first I'm going to add 2 pi. So if we think about adding fractions, we want to get a common denominator. So I'll still have pi over 6, but I'm going to turn the 2 pi into 12 pi over 6. And that way I can actually add my two fractions because they both have a denominator of 6. So we have 13 pi over 6. So that is one coterminal angle to pi over 6. So now let's say I subtract 2 pi. So I'll have pi over 6 minus 2 pi, which would be pi over 6 minus 12 pi over 6, which would be negative 11 pi over 6. Okay, so now let's suppose that we add 4 pi. So what if I did pi over 6 plus 4 pi? Well, that would give me pi over 6 plus 24 pi over 6, which would just be 25 pi over 6. And then finally I could subtract 4 pi. So I could take pi over 6 minus 4 pi, which would be pi over 6 minus 24 pi over 6, which would be negative 23 pi over 6. So those are our 4 coterminal angles to pi over 6. And the final angle I want to look at is negative pi over 2. So let's do the same thing. So we're going to add we're going to add 2 pi, we're going to subtract 2 pi, we're going to add 4 pi, and we're going to subtract 4 pi. So I'm going to start with negative pi over 2 plus 2 pi, and this time I want my least common denominator to be 2. So I'm going to have negative pi over 2 plus 4 pi over 2. So the way to write 2 pi with a denominator of 2 is 4 pi over 2, and if I add these, I'll get 3 pi over 2. So now let's say I want to subtract 2 pi. So I have negative pi over 2 minus 2 pi, which is negative pi over 2 minus 4 pi over 2, which is negative 5 pi over 2. And now let's say I want to add 4 pi. So I'll have negative pi over 2 plus 4 pi, which is negative pi over 2 plus 8 pi over 2. So this would be 7 pi over 2. And then finally I'll have negative pi over 2 minus 4 pi, which is negative pi over 2 minus 8 pi over 2, which is negative 9 pi over 2. Okay, so those are my 4 angles that are coterminal to negative pi over 2. Okay, so the final things we're going to talk about in this section are some really simple word problems. So the first one we're going to talk about is what we call arc length, and the next one we're going to talk about is the area of a sector. So with arc length, what I want you to think about is if you had a pizza, I want you to think about arc length as finding the length of the crust around the pizza. Okay, so in a circle of radius r, the length s of an arc, so think of the arc as the pizza crust, that subtends a central angle of theta radians is s equals r theta. Okay, so what this is saying is we're finding the length of the pizza crust on a particular slice of pizza. Okay, so for our first example, we have a circle has a radius of 4 inches. Find the length of the arc subtended by a central angle of 240 degrees. So there is one main thing you want to notice about this formula. So when I say theta is your angle, make sure to remember that theta is in radians. But notice that the angle in our problem is in degrees. So before you even do the formula, the first thing we need to do is get our angle into the correct units. So we need to take 240 degrees and we need to change it into radians. So we're going to have pi radians over 180 degrees, which if we put in the calculator, should give us 4 pi over 3 radians. So this is the angle we're going to use, not 240. Okay? So our formula is S equals R theta, where S is the arc length. So this is the arc length. R is the radius. And theta is the angle. Okay, so when we want to plug in our information into S equals R theta, we know that the radius is 4. So we're going to put 4 in place of R, and we're going to use 4 pi over 3 in place of theta. So S we get by multiplying the two numbers. So we get 16 pi divided by 3. And since we were given a unit on the radius, the arc length is going to use that same unit. So if you measure the radius of your pizza in inches, the crust is also going to be measured in inches. Okay, so our arc length, we want to use that same unit. So we're going to have 16 pi over 3 inches. Okay, let's do one more example with arc length. So in this one, we have a central angle theta in a circle with radius 6 meters is subtended by an arc of length 12 meters. Find the measure of theta in radians. So let's go ahead and write our formula. So we have S is equal to R theta. Okay, so S is arc length. Well, in our problem, we're given an arc of length 12 meters. So we can go ahead and put 12 in for S. Our radius is 6 meters, so we can go ahead and put 6 in for R. And we're looking for theta, so we're going to leave that as our variable. So all we need to do to solve for theta is we need to divide 12 over 6, which we can do that. That's 2. So 2 is the measure of theta. So remember that theta is already in radians, so we actually don't need to do any conversion here. Theta is in radians, so this is good to go. Theta is equal to 2 radians. All right, so the last type of word problem we're going to talk about in this section is called the area of a sector. So whereas arc length was the length of the pizza crust, I want you to think of area of a sector as like the area of the pizza slice. Okay, so if your circle is the pizza, a sector is like a slice of the pizza. So in a circle of radius r, the area of a sector with central angle theta in radians is 1/2 r squared theta. So once again, theta is always in radians. So if they give it to you in degrees, the first thing you need to do is change it to radians. R is again the radius, and then A is just going to be area. So we have area, radius, angle. And that 1/2 is just an extra number in the formula. So let's look at our problem. It says find the area A of the sector of a circle of radius 2 feet formed by an angle of 30 degrees. So once again, my angle was given to me in degrees. So the very first thing I need to do is change it into radians so that I can use my formula. So 30 degrees, we can multiply by our conversion factor. We can put pi radians on the top and 180 degrees on the bottom. And if I do that in the calculator, I should get pi over 6 radians. So the theta that I'm going to use is pi over 6. So now let's write the formula. So we have area is equal to 1/2 r squared theta. I was told my radius is 2, so I'm going to have 1/2 times 2 squared times pi over 6. So now let's multiply all of this. So 2 squared is 4, so I have 1/2 times 4 times pi over 6. 1/2 times 4 is 2, so I have 2 times pi over 6, which is pi over 3. So my area of the sector is pi over 3, but I need to make sure that I add units. So just like in the arc length, we're going to have units for the area of a sector. Now an area's units always are squared. So for arc length, we just took the same units as the radius. For area, we're going to take the unit of the radius, but we're going to square it. So since the unit of the radius was feet, our area is just going to be feet squared. So our full area of the sector is pi over 3 square feet, or feet squared.